Hi guys, welcome to my YouTube channel, Field of Science. Myself Rohit. Today we are discussing about the chapter Physics Class 11, System of Particles and Rotatory Motion. We may expect 1 to 2 questions from this chapter. This chapter is somewhat easy. Okay, without wasting any time, we start the chapter. First we come to center of mass. Then what is center of mass? Center of mass means total mass of the body appear to be concentrated at one point is called center of mass. Means whole mass of the body is concentrated at one point is known as center of mass. See, for ring center of mass is the center of the ring, and for disc also center of the disc there is center of mass is concentrated. For the triangle, intersection of the diagonals here, intersection of the diagonals, this point is known as center of mass. And for the square, center of the intersection of diagonals, this is intersection of medians, this is intersection of diagonals. In rectangle also intersection of diagonals. For sphere, for sphere also center of the sphere is known as the center of mass, its center of mass. For cone, it is situated, center of mass is situated 3h by 4 distance from the apex. This is apex. 3h by 4 distance from the apex is known as there the center of mass is situated. Then we come to coordinates of center of mass. How to find the coordinate of center of mass? See here. If object M1 and object M2, its center of mass is situated in center here. This is object, center of mass is here. How to find the center of mass coordinates? See here. This is y-axis, this is x-axis. From M1, x1, distance is x1. From CM to y coordinate, xcm. From y-axis to M2, x2. Then distance between M1 and center of mass is d1, and center of mass to M2 is d2. Whole system, the center of mass is from M1 to M2 is, the distance is d. How to calculate this? xcm, center of mass, x center of mass is equal to x1 M1. Here, x1 M1 plus x2 M2 by M1 plus M2. We have to find this. This we have to find means we have to use the formula xm is equal to x1 M1 plus x2 M2 by M1 plus M2. This is along x axis. If along y or z means y or z axis means then x coordinates. In case of these x coordinates, we have to use y1 M1, y2 M2 by M1 plus M2 for ycm. So if you want to find the ycm, if you want to find the zcm means z1 M1 plus z2 M2 by M1 plus M2. Okay. In case of velocity cm, means center of mass of velocity and the center of mass of acceleration, if you want to find this, the formula is center of mass of velocity is equal to m1 v1 plus m2 v2 by m1 plus m2. In case it is moving, both are moving in opposite direction means the plus will become minus. For acm, m1 a1 plus m2 a2 by m1 plus m2. This minus will become minus if they are moving in opposite directions. Method to locate center of mass. Let's move on to how to locate the center of mass. First method is symmetry method. Here, first for circular disc. In case of circular disc, here two discs are joined together. Radius 1 for one disc and radius 2 for another disc. The center of mass, both center of mass, center, the distance between is d. Take one center of the ring as origin and then calculate. See here, xcm is equal to m2d by m1 plus m2. How means m2, this is m2, this is m1. See here, according to like this formula. See here, m1 we know, but x1 0, so it will be cancelled. Here, m1 x1 plus m2 x2 by m1 plus m2. Here x1 we don't know, 0. This is 0. So this whole term becomes 0. So x2 is d. So x2 is d. So the formula came as like this. xm is equal to m2d by m1 plus m2. What is m2? By r2 square rho t, mass of this, into what is distance? See distance r1 plus r2. So r1 plus r2 whole divided by m1 plus m2. m1 means pi r1 square rho t plus pi r2 square rho t. Then xm is equal to On solving this, you will get as r2 square into r1 plus r2 by r1 square plus r2 square. Then we come to sphere. By calculating like this, we will get this as xm is equal to r2 cube into r1 plus r2 by r1 cube plus r2 cube. Then for 3 rod system like this, if one rod is here like this L1 and another rod is L2 like this length L2. Center of mass is located here. How to find the center of mass? See here. YCM is equal to L2 square by 2 into L1 plus L2. This is also calculated by like this only. Remember, if you can't do like this, just remember this formula, you will get the answer. Next, two cylinder system. See here, one cylinder is like this and another cylinder, small cylinder is joined like this. How to locate this center of mass? See here, its center of mass is, this is C1 and this is C2. But how to locate this system center of mass? Here, it will come as here. So by doing like this only, we can get this as xm is equal to r2 square L2 into L1 plus L2 by 2 into r1 square L1 plus r2 square L2. Next method is decomposition method. Here, decomposition method, if they given like this in the question diagram in axis, this is x, this is y, this is x. First, you have to divide this into 3 masses. Here, this is one mass m1 and this is m2 and this m3. Just do like this and locate the center of mass by doing coordinates. Here, coordinates x1 y1, x2 y2, x3 y3. Okay, by using this you can find the xcm. Okay, xcm and ycm and zcm. Then we will get the center of mass of all these objects. Then we move on to third method is integration method. See here, how to find the through integration method is, there is one formula xcm is equal to integration of x dm by integration of dm. See here, if they given in a question, for example, linear, if they given linear density lambda is equal to a plus bx, then if you want to find center of mass, then you have to use this formula. See here, first lambda is equal to dm by dx. Am I right? Lambda is equal to dm by dx. Then what is lambda? A plus bx. Then move this into here. Then dm equals a plus bx into dx. Yes, we get the dm. Then these values are applied in this formula. See, xm is equal to integration of x into dm means this, and divided by integration of dm means this. Then what the integration value will get this answer. Next, we discuss about shifting of center of mass. Shifting of center of mass. First, for example, if this is the rectangle of mass capital M, and if we remove this hexagon of mass m from this rectangle, what, for which distance the center of mass will be shifted? From here to here is known as xs, means center of mass, shifting of center of mass. How to find? By this formula. See here, center of mass xs, shifting xs is equal to small m, means this mass into m into distance between the center of mass of this hexagon and the center of mass shifted by capital M minus small m. By using this formula, we can derive all these formulas. Okay. See here, for ring, for here disc, if you remove a small circle from here, there is a distance between this cap. Okay, this cap is the distance. Then we will get the formula like this: x is equal to r square d by capital R square minus r square. For this disc, we remove by touching this here. These two circles are touching. Then the formula will come as r square by r plus r. For rectangle, if we remove a circle, then shifting of center of mass x is equal to L pi by root 2 into 60 minus pi. Next, we move on to rotational motion concept. In rotational motion concept, I have to discuss about moment of inertia. What is moment of inertia? Moment of inertia means I is equal to mr square. M means mass of the object and r means distance between the center of mass and the axis of rotation. This is called as moment of inertia. Moment of inertia depends, see here, note point, moment of inertia is a tensor quantity. Remember, it is a tensor quantity. It depends on a mass distribution and the distance. See here, mass distribution and the distance. This is very important question asked in the NEET exams. Then finding the moment of inertia, two methods: perpendicular axis theorem. two theorems. Perpendicular axis theorem, first theorem is see here. This is the circle, means this is x axis, this is y axis, this is z axis. How to find the moment of inertia here? If you want to find the moment of inertia in z plane, iz moment of inertia z plane, then we have to add moment of inertia of x axis and moment of inertia of y axis. If you want to find in xz plane, we have to find in xz plane, then we have to add ix plus iz, then we will get the iy, moment of inertia of y. Then this also like that only. Next, second method is parallel axis theorem. See, parallel axis theorem, it rotate in a perpendicular axis like this, it will rotate. For here, this is object, this is center of axis, but it is rotating parallel to here. See, this is rotating like this. Here it is rotating here, but center of mass is here. Okay, see here, moment of inertia is equal to moment of inertia of this rod through perpendicular axis. Moment of inertia of this rod perpendicular axis IC plus m into mass of this object into x square, distance between the parallel axis, which it is rotating square. Okay, I is equal to IC plus mx square distance. Okay, next, for uniform rod, what is moment of inertia? I is equal to ml square by 12. Remember it. Okay, I is equal to ml square by 12. And for rectangular lamina, here perpendicular, according to perpendicular axis theorem, moment of inertia of uniform rod is ml square by 12. According to parallel axis theorem, moment of inertia of uniform rod is I is equal to ml square by 3. Then for rectangular lamina, moment of inertia is equal to m by 12 into L square plus B square. For square lamina, moment of inertia is equal to ml square by 6. Next, we move on to this table. This is very important table, which we can understand whole moment of inertia in this concept only. If we don't know these values, then we can't solve the problems of the moment of inertia. About an axis passing through center and perpendicular to plane. See here, this is a ring. Means perpendicular axis, it is rotating perpendicular axis with a plane. Here, this is plane acting perpendicular to the plane. Okay. Then for ring, moment of inertia is I is equal to mr square. For disc, I is equal to mr square by 2. Okay, here there is no divided by 2, here divided by 2. Just remember like this. For second, about an axis passing through tangent and perpendicular to plane. Here, it is perpendicular to plane, but tangent. According to tangent, this is rotating like this. This whole system rotating here like this. Okay, perpendicular axis, but through tangent. Okay, through tangent. Then for ring, moment of inertia is equal to 2 mr square. For disc, moment of inertia is equal to 3 by 2 mr square. About any diameter, means diameter through the plane, diameter through the plane. Here, for ring, through the plane. For ring, moment of inertia is equal to I is equal to mr square by 2. For disc, I is equal to mr square by 4. For about any diameter, for about any tangential diameter, here, diameter tangentially, here, tangentially it is rotating, it is rotating like this. Then for ring, moment of inertia about tangential diameter is I is equal to 3 by 2 mr square. For disc, I is equal to 5 by 4 mr square. Then come to solid sphere and hollow sphere. About diameter, about diameter for solid sphere, I is equal to 2 by 5 mr square. For hollow sphere, I is equal to 2 by 3 mr square. About tangential diameter, tangentially diameter. For solid sphere, tangentially diameter, I is equal to 7 by 5 mr square. Solid cylinder and hollow cylinder. Several disc, if we join the several discs, we will get the solid cylinder, and if we join the several hollow ring, then we will get the hollow sphere. So here, for solid cylinder and hollow cylinder, the moment of inertia is like what? This ring and disc. Here, about its own axis, solid cylinder I is equal to mr square by 2. For hollow cylinder, I is equal to mr square. About an axis perpendicular to one axis, solid cylinder, moment of inertia is equal to mr square by 4 plus ml square by 12. And for hollow cylinder, I is equal to mr square by 2 plus ml square by 12. About an axis perpendicular to one axis. Okay. Note point here. Moment of inertia is inversely proportional to density. See here, moment of inertia is inversely proportional to density. In exam, they will ask the relation. So I1, moment of inertia 1, I1 by I2 is equal to del 2 by del 1. Here I1 by I2 is equal to del 2 by del 1. Next we move on to torque concept. Torque concept here, turning effect of force is known as the torque. What is torque? Turning effect of force means turning effect. If we rotate the cap, the force is acted here also as well as here also. So here, if we rotate the cap, the force acts here and here. This is known as the torque. Here, torque is equal to turning effect of force. What is the formula of torque? Torque is equal to R into F. Here, radius into force acted. What is the unit? Newton meter. Torque is equal to another formula also therefore represent the torque. Torque is equal to moment of inertia into angular acceleration. See, moment of inertia into angular acceleration. In terms of angular momentum, torque is equal to dl by dt. Remember it. Torque is equal to dl by dt. Let's come to principle of moments. Principle of moments states that, see here, if if they have two forces, it has to balance means F1 d1 equals F2 d2. This F1 d1 must be equal to F2 d2. So this will be balanced here. It will does not vary anywhere. Torque 1 is equal to torque 2. So then only it is in rotational equilibrium. Okay. If the system, if you want to rotational equilibrium, come to rotational equilibrium, F1 d1 is equal to F2 d2. It must be happen. Okay. Next come to angular momentum. What is angular momentum? Product of linear momentum and the perpendicular distance. Remember, product of linear momentum and perpendicular distance is known as angular momentum. Here L is equal to R into P. P means angular linear momentum. R means perpendicular distance. Okay. P means mass into velocity. Am I right? Mass into velocity. See here, L is equal to mvr sin theta. Mv means P. Mvr sin theta. L is equal to mvr. Another formula for angular momentum is L is equal to moment of inertia into angular velocity. I into omega. See here, I into omega. See here, this is like, see here, momentum. Linear momentum is equal to m into v. Here, angular momentum is P. In case of P, L. In case of m, moment of inertia. In case of mass, moment of inertia. In case of velocity, angular velocity. Next come to kinetic energy concept. Kinetic energy, two types of kinetic energy. Here, translational kinetic energy and rotational kinetic energy. For translational kinetic energy is equal to 1 by 2 mv square. See here, 1 by 2 mv square. For rotational kinetic energy is equal to 1 by 2 I omega square. This is like translational kinetic energy. But see here, in case of mass, here moment of inertia is used. In case of velocity, here angular velocity is used. Kinetic energy in terms of angular momentum is here. This relation is asked more times in NEET exam. Kinetic energy is equal to L square by 2a. More problems are asked by this formula, L square by 2i. K is equal to L square by 2i. And K is equal to L omega by 2. Angular momentum into angular velocity by 2. Kinetic energy is equal to angular momentum into angular velocity by 2. Then kinetic energy is inversely proportional to moment of inertia. Here, kinetic energy is inversely proportional to moment of inertia. So K1 by K2 is equal to I2 by I1. This relation also asked in NEET exam. Next come to work energy theorem. What is work energy theorem? Okay, work energy theorem states that work is equal to change in final rotational kinetic energy minus change in initial rotational kinetic energy. This rule is studied in work energy power theorem, but it is translational kinetic energy. Here, rotational kinetic energy. W is equal to 1 by 2 I omega 2 square minus 1 by 2 I omega 1 square. W is equal to 1 by 2 I omega 2 whole square minus omega 1 whole square. Next up to rotational power. What is rotational power? In case of normal power is equal to W by T. But in case of rotational power, here W means what? F into S. In case of rotational power, F means torque and S means angular direction, angular displacement theta by T. So T theta by torque theta by T is equal to torque omega. See here, theta displacement by time means velocity. Velocity means in case of rotational motion is omega and the angular velocity. So torque into omega. Next come to angular impulse. Normal impulse F is equal to force into time, but force in case of angular means torque. So J is equal to torque into time. Next come to law of conservation of angular momentum concept. See here, in the absence of torque, if the torque is not present, the total angular momentum of the system remains constant. Remember here, in the absence of torque, thus the torque is not present, the total angular momentum of the system remains constant. It remains constant. Okay, torque is equal to dl by dt. If dl by dt equals 0, then means there is no torque. Then I1 omega 1 is equal to I2 omega 2. Okay, if there is no torque, angular momentum remains constant. If angular momentum remains constant means 0. So I1 omega 1 is equal to I2 omega 2. This is known as law of conservation of angular momentum. We can study an application. Okay, see here. If this ring is rotating like this of moment of inertia I1 and another ring is I2 in this direction, then if they coupled each other, first it has moment of inertia I1 with angular velocity omega 1. Here I2 with angular velocity omega 2. If they coupled each other, then what happens? If they coupled each other, then I1 omega 1 plus I2 omega 2 means this is equal to total this coupled I1 plus I2 into omega. The moment of inertia will both added and they both rotate in the same angular velocity omega. Okay now, if in opposite direction, this arrow marks it in opposite direction, then I1 omega 1 minus I2 omega 2 is equal to I1 plus I2 into omega. Next, come to rolling motion. Rolling motion means translatory motion plus rotatory motion is equal to rolling motion. If the body must be rolled means it must shows translatory motion as well as rotatory motion. See here, velocity at any point for rolling body. If you want to find the velocity of at any point here for rolling body, then we should use the formula this. Here v dash is equal to 2 v sine into cos theta by 2. Theta means the angle between these and these. Okay, diameter and the center means the point where it here. For this point, according to this formula, we will get 2 VCM. For this point, root 3 VCM. For this point, root 2 VCM. For this point, 0 VCM. Okay now. Next, kinetic energy of rolling body. Kinetic energy of rolling body, how to find? Here, kinetic energy of rolling body means we have to add kinetic energy of translatory motion as well as kinetic energy of rotatory motion. Okay, then we will get kinetic energy of rolling motion. See here. Kinetic energy of rolling motion 1 by 2 mv square into 1 plus k square by r square, we will get the answer. How we derive it? Kinetic energy of rolling motion is equal to 1 by 2 mv square kinetic energy of translatory motion plus 1 by 2 I omega square kinetic energy of rotatory motion is equal to 1 by 2 mv square plus 1 by 2 m k square. Moment of inertia means m k square and omega means v by r. So omega square means v square by r square. Then see here. Then taking 1 by 2 v square mv square as common, then we will get ku rolling is equal to 1 by 2 mv square into whole 1 plus k square by r square. Then for ring or hollow sphere, k square by r square what? Here m square mr square. For ring, moment of inertia is equal to mr square is equal to mk square is the normal moment of inertia. Okay now, then k square by r square is equal to 1. Cancel, so k square by r square is equal to 1. For disc also, we will get as for disc or solid cylinder to mr square by 2. Here mr square by 2 is the solid cylinder moment of inertia, mk square. Then what will get? 1 cancel, k square by r square is equal to 1 by 2. Like solid sphere also, k square by r square is equal to 2 by 5. I hope you heard understand the what I taught today. So thank you for watching. Please don't forget to subscribe and like this video. If you want my short notes for revision, just subscribe and just follow and message me on Instagram or Facebook at filmy.and Facebook Rohit. It will help you there. Thank you so much. Bye bye guys.